One-tailed sample t-test, dependent or paired. Here are the assumptions for the t-test for two means when the samples are dependent.
The sample or the samples are random. The sample data are dependent. When a sample size is less than 30, the population must be normally distributed.
Since it's already springtime, we're currently browsing some flower shop documents regarding their sales. And it goes like this.
A sample of 9 flower shops showed their sales 3 years ago and their sales today. At alpha 0.05, can it be concluded that the average in the sales for the flower shop is greater today than it was 3 years ago? To answer this, we followed several steps.
Step 1. State the hypothesis and identify the claim. Since we are interested to see if there has been an increase in sales, the sales 3 years ago must be less than the sales today. Hence, the differences must be significantly less 3 years ago than they are today. Hence, the mean of the differences must be less than 0.
The null hypothesis, or H sub O, the mean of the differences is equal to 0. The alternative hypothesis, or H sub A, the mean of the differences is less than 0, which is the claim.
Step 2. Find the critical value. Decide on the significance level of its alpha.
The degrees of freedom is n minus 1. Since Rn is 9, then 9 minus 1 is equals to 8. The critical value for a left-tailed test with alpha 0.05 is negative 1.860, which is raised from the table.
Step 3. Compute the test value.
First, make a table.
In the first column is the sales 3 years from now, which is the x sub 1.
In the second column is the sales now, which is the x sub. In the third column is the difference of x sub 1 and x sub 2.
And in the fourth column is the square of x sub 1 and x sub 2.
Summation d is equal to 9.73 and summation d squared is equal to 40.5437. Then, find the mean of the differences. D bar is equal to summation of d over n. Negative 9.73 over 9 is equals to negative 1.081.
Then, find the standard deviation of the differences.
Solving for standard deviation, you can either use the formula or you use your calculator. Then, find the test value. T is equals to d bars times square root of n over sd. Negative 1.081 times square root of 9 over 1.937 is equals to negative 1.67423813.
Step 4. Compare the test value and the critical value.
Negative 1.67 is greater than the critical value, negative 1.860.
Step 5. Summarize the results, state a conclusion.
The absolute computed value is lesser than the absolute critical value. Therefore, the null hypothesis is accepted and the alternative hypothesis is rejected. Hence, the average in the sales of the flower shop is not greater today than it was 3 years ago.
Yes! We survived a spring problem!